Welcome to our unit today, that is Toolroom Processing Technology 1. Our today's topic is about code working. So, what is code working? This is also referred to as code forming. In this case, the metal is shaped below its crystallization temperature, usually at ambient temperature. Code working processes include the following. We have loading, drawing, code spinning, forging, stretch forming, flow forming extrusion, etc. Let's discuss each of these. We start with the rolling. What is rolling? This is a metal forming process in which the material stock is passed through one or more pairs of rolls to reduce its thickness. So you find here that the rolls are used for various sizes. So and the material is passed through the rolls to reduce the size or the thickness of the material. We have drawing. What is drawing? This is a metal working process that uses tensile forces to elongate metal. As the material is drawn or pulled, it stretches and becomes thinner, achieving the desired shape and thickness. Examples are sheet metal drawing, wire drawing, tube drawing, etc. etc. Now, students, it's an assignment for you. Do further reading on the remaining types of code work processes. Especially the code spinning and the flow forming extrusion. Now, let's look at the effect of code forming on material structure and property. Code working causes the crystals, grain, and inclusions to distort following the flow of the metal. This may cause work hardening and an isotropic material property. Work hardening makes the metal harder, stiffer, and stronger. However, the material becomes less plastic. So what is plasticity? Plasticity is the ability of a solid metal to undergo permanent deformation, which is an irreversible change. So cold worked items suffer from a phenomenon known as elastic springback. Elastic springback is a phenomenon where the material bounces back to original or almost original size once the load or the deforming load is relieved. Ductility is also decreased in cold worked materials. Let's now do the analysis of stress strain curve in code forming. Stress strain curve provides the design engineers with important parameters needed for the application design. Mechanical properties given by the stress strain curve include the following. We have the strength of the material, the toughness of the material, elasticity, yield point, strain energy, resilience, elongation during the load, and many others. So you find all these properties of the material we can be able to analyze them or to get them from the stress strain curve. So this is the strain curve. This is how it looks like for a metal like mild steel. So you find in the x-axis we have the strain versus the stress in the y-axis. If you look keenly on the diagram, you find that from point 0 to point A, there's a straight line. So it means at this point, as we apply the load, the metal is deforming linearly. And in this section is where now the material is elastic. That means if the load is relieved at this point, at this region, the material will go back to its original size. Now, you can see from the diagram that after B, the curve changes and it starts forming a curve all the way to D and E when the material fractures or fails. So the maximum height of the diagram D at point D is where we call it the ultimate strength of the material. At the point B, that's what we call the yield strength point. Maybe something to note here that on the linear section of the diagram, that is from O to A, the slope of that diagram gives us what we call the Young modulus, which is given by stress divided by strain. And the area under that straight section, we call it modulus of resilience. And of course, the total area from A to A gives us the modulus of toughness before the material eventually fails. So let's go now to the next. Try to analyze what you have just seen in the diagram. It's a diagram, a stress strain curve is a diagram showing the relationship between the magnitude of the applied stress on a material and the resulting strain or the elongation caused by the cost to the material, as you have seen in the diagram. Stress in engineering is denoted by the Greek symbol sigma. Stress is an applied force in meters of a given area in squared millimeter. So you can see the expression of stress is equals to Newton per given area in millimeter squared. Then what is strain? Strain is denoted by the Greek symbol epsilon. You can see how it is written. It is defined as the length of elongation in millimeters divided by the original length of the material in millimeters. So from that definition, you can see that the strain does not have unit because it is length divided by a length. So it is normally expressed as a percentage. Young modulus. Now, Young modulus, as I told you, is the slope of the linear part of the stress strain curve and is known as the Young modulus or denoted by the symbol E. It is also referred to as Young modulus of elasticity because at that section is when the material is elastic. Yield strength. After the linear deformation of the material, the plastic deformation sets in if the load continues to be applied. This is known as the yield. The loading stress value that causes this yielding to occur is known as the yield strength. Failure of structural design often occurs when a structural material experiences a load value larger than its yield strength. So you have seen if the load exceeds the yield strength, then there is fracture at point E from the diagram. That is the end of our lesson today. Thank you for listening to me. Bye bye.